Today we're going to be looking at the idea of relationships and databases. And so what I want you guys to be doing is working on taking notes with this and doing screenshots as necessary. Again, this will be posted on YouTube so you'll have access to it. But we want to make sure we have some work for this. We're looking at the idea of relationships in database design now. We've been doing some database work in class and we've done some stuff with it. As you can see over here on the left of my PHP admin screen, we've got a new database called Reading. And on that, I have 4 tables. I have authors, books, book genre, junction, and genres. And so we're going to be using those tables to address a couple of different issues that are attached to relationships. And we're going to use that to examine what's going on with that. So I'm going to go ahead and shrink that slide down so we can have more screen space dedicated to our actual structure. We can take a look at that. So going back over to actual database structure right here. As I said, we're going to be looking at doing a couple different database projects where you're going to be using your database controller to interact with multiple databases, plural. One of those that we're going to be interacting with is a database based on some books. And so I've got a couple different pieces of information here we're going to be going over and seeing how they relate to things using the ideas of one-to-one, one-to-many, and many-to-many relationships using MySQL. As you can see right here on the left top area, we have the authors tab, or excuse me, not tab. We have the authors table, the books table, and the genres table. I'm skipping the book genres junction table right now to start off with because we're going to explain that one as we hit it. If we take a look at our books table, it will look just like basically every table we've made so far. We click on the structure link, of course, first, making sure we actually look at it. And we've been using the idea of a synthetic key all year long. We're going to continue with that with a synthetic key called ID here again, just an int that auto increments, and we can have that generated with it. We have the title of the book, and that is a varchar. I specified it for 50 characters. We could do more, but I figured that'd be a good start for basically most books. We have a red year. The red year field is an int. This goes to the fact that the data source we'll be using, I did not incorporate actual dates as to when books were read, especially since some of them have been reread n times, and so we're going to be putting information in with that. We also have an author field, which is an int and an isbin. And if I go ahead and look at the relation view for this table, again showing the relationship of one thing to another, if I click over here, you can see that the author field is a foreign key field. So it links to the authors table, linking to its ID field on that, so that we have a direct foreign key relationship right here. And for my onDelete, no action, my onUpdate cascade, so that any changes that I make will go updating it on a positive fashion. Any deletion changes, I just leave it. So it's going to set for no action on that, so it will be removed. Because I'm not going to allow nulls to happen, so I can't do just simply remove it like that. I could have a remove on there, but I want to actually keep this at this point to just be no action. And those are the only indexes that we're using. Going back to the structure for that, we also have the ISBN category. Anyone know what ISBN is? Yeah, International Standard Book Number. It's just basically a giant way of keeping track of books so you can find them numerically, because for some crazy reason, if you change the title because of a language change, you still want the same book. And so the ISBN is how you can keep track of that, and they have publishers have specific things. One of the really nifty things about ISBN is it's actually an algorithm, and you can find out information about the book itself by looking at the algorithm, specifically the publisher. I'll have you guys take a look at an article about that later on this year, but just as an FYI, that's something you can do with that. Going back to the database, we also have our authors tab. My authors table, we have first name, last name, nationality, just because I can throw something in there for that, as well as a pseudonym. And we're going to make a change right now on nationality. I'm going to make it so that it can be null because we don't necessarily know the nationality of everyone on there. So we'll put a checkbox on null for nationality and hit save. We'll do the same thing also for pseudonym because some authors don't use pseudonyms. And so we'll add that null feature to that as well. So we've made a couple changes on that. So we've altered our table for the authors table to make it so that we can make sure that both nationality and pseudonym can be null, because not all authors will have those two characteristics. Again, we want to plan that out so we have that. We're going to go take a look finally at the last table we're looking at right now, the genres table. And the genre table has simply an ID and a name. And this is where we're going to be using this specifically for the idea of the many-to-many relationships. We're going to hit that in just a second. But what we'll talk about right now is first we're going to look at the idea of the structure between one-to-one and one-to-many. So to do that, we go back to our database itself as a whole, and we have in here our authors, books, and genres tables. For those first two relationships, the one-to-one and one-to-many, we're going to take a very simplistic look at books. Every book has an author. Yes, I know books do have n authors, where n is some number possibly that's greater than or equal to 1. But for purposes of this version of the database, we're going to keep it simple and easy, where every single book has one author, just to make it so we can keep track of things a little bit better. So that is a one-to-one relationship. Every book will have one author. However, we also have in that a one-to-many relationship. One author can author many books. So the same author can be attached to many books, even though one book has only one author it is linked to. And so the one-to-one and one-to-many relationships are very simple, easy to see, no big deal, nothing hard to worry with. Where we come into play, though, is the idea of that many-to-many relationship. Showing a many-to-many relationship inside our structure is a problem, because the idea of our normalization of data, where if I go in, say, into my book thing, and I add in my structure, I add a genre field right here, my genre field would have lots and lots of comma-separated entries. And the whole point of having a normalized set of data is that we don't have multiple entries in one single field. And so to avoid that, but still maintain that idea that there is a many-to-many relationship where a book can have multiple genres, and books in general relate to different genres as a whole, where we have a many-to-many relationship. Many books will have many different genres. And so in order to do that, we are going to create what's called a junction table or a helper table. And that allows us so we can actually maintain the idea of having a many-to-many relationship. Because otherwise it just gets into a giant pile of mess. I'd have to go in here and I would add a thing right here called genres. It would be a varchar. And I would have to put, like, say 100 or whatever, some ridiculous number, 1,100 on that. And it could be null. Because there are some books that actually have no genre at all. There's no style to it. It's just book. I mean, it's not even like, I guess, you could say the phone book. And I could theoretically start reading phone books again. And although that I don't recommend that for myself, that would be a valid entry for the idea of genre. And so when I enter a genre, I'd have to go through and actually have all these different values in it that it could have. And then the bad part, what makes the idea of having comma-separated values a big problem in a database and why we want to normalize, is what if I want to find all the books that fit a certain genre? Now, if I go through and I have to look through every single genre field on here to see if that text contains a string, that is going to be a lot of processor-intensive work. The database will have to be doing lots of work just to find out if it has in a field one genre. What if I want to see if all the books that have two different genres? So first I have to look for all of this and then look for this and see if they're both at the same time. And so that's extra logic on there. Now, it's programming logic-wise not that much work, but the structural logic that goes along with that and the time it takes to store it is much more. And because of the fact that genres are a limited amount, even though there are many of them, there will be less genres than books most likely. Our data source that we're going to be using to work with this, I have approximately 900 different books that I've read for the last few years. And so we'll be using that as our data source, and as such, I only have on my genre list, I only have, say, 10 genres. But some books will fit within multiple genres. And to search that and to do queries based on that, we want to make it as easy and as well-defined as possible for us. So we're going to go ahead and we're going to get rid of that genres field on there, on our structure, because we don't want to have a genres field in this. And so yes, I really want to execute that alter table book drops that column, and say OK, and say bye-bye genres. And so instead, when I go back to my database, and I look at my structural component for my book genres junction, and look at its structure, I have in my book genres junction table, a little bit different setup. I have the standard synthetic key of an ID. I have then a genre ID and a book ID. So what will happen is each entry in this helper table, in this junction table, I'll have a book ID and the genre ID that I'm specifically assigning for it. So that way I can have multiple books with the same set of entries. So I can have, say for example, I pick on Harry Potter. Harry Potter, I have multiple genres it'll fit in. It is a fantasy novel. It is a book that I read with my family for a second one. For a third one, it's one that I've reread with my family more than once. So I have 3 separate genres. So I'd have the same book ID, but with 3 different entries in that genre ID field. So that book will then occupy at least 3 rows. Because each of those 3 things are 3 separate and discrete values. And so that's the whole point of having this helper table. I can have that many-to-many relationship where many books have many genres. But I have it discrete and separated out by having this little helper table where I can link to what genre it is at that point with that book. And since each book can have different combinations on that genre ID, I can show that idea of a many-to-many relationship. Now, just to make sure you guys don't think this is just, oh, Henriksen is doing this to give us work to do. No, 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 no. This is actually something that's a really big deal because you find this most often in the biggest thing that databases are used for. Selling crap on the internet. Now, who has bought stuff on a store online? Okay, many humans have raised their hand. Fantastic. Who has bought the same thing from the same store more than once? Like you've bought more than one thing of RAM. You've bought more than one processor. Of the same kind even, possibly. Or you've bought more than one set of food. Who has shopped at papajohns.com or some other website to buy food online? Okay? You will have multiple entries in their databases, even if you order the exact same thing. Because they want to keep track of, oh, I ordered this then, and they ordered it this other time. So I'm keeping track of these different pieces of information. Or, say for example, you order, and on different orders you have different sets of things. And so each set of things is a different thing. And so this idea right here of this helper table allows you to have, I have an order with Amazon. My order has different order items and order quantities. But I go and I make another order, and I'll have, again, separate order items. So the order items could be the same different thing at a different quantity, but it's all on a separate order, so I can keep that separated out. Because Amazon has their product that they're selling, but it's separate from when you're buying it. So they link it together with this idea of a junction table. That way I can keep things that are separate, but bring them together for this purpose and keep track of them because I'll do it more than once. And so the helper table is what that happens. So to see how this is working, let's take a look at its relationship view. And as you can see here, on the relationship view, I have my synthetic key, of course, my primary key. And then I have my genre ID, really creative naming here. My genre ID links to the genre table ID field. And then my book ID, also very creative, links to the books table for its ID field. So this helper table or junction table, again, put that in your notes, please. The idea of a helper table or junction table is basically just taking a bunch of information from 2 separate tables and making it so I can access specific information for it right here. I could avoid doing this, like I said, by making a gigantic set of fields that expands and contracts inside my books table. The problem with that, though, is I would not be able to make any clean extractions, and then adding genres to books would become difficult. Say, for example, I want to add a new category to books, like say books that I've read on Kindle as a genre or as a category. And I'm going to go back and add that to all my books, but I can't just simply go through and just do that with it when it's simply an entry in a field. But by doing this, I can simply just select all books that have certain category matchings and then add that row to this field with that. So it makes it so I can go really fast and add lots of more features to things by doing that, so I can make changes. This is a huge feature for doing database development. And so I can have different relationships shown on things. So to do so, I'm going to go back to my database over here. And I'm going to go to my data dictionary link right here. And this brings up a print view, so we can actually see how my structure of my database is set up. And so we have our different tables that we have right here with a list of our indices as well. Again, a nice little feature of showing what we're doing, so we can see that. Again, it's the data dictionary for this view. And so I can see what we have on this information. Again, you note that we allow the null to happen on there. And the nice little feature right here on the junction table that we see specifically is that links to field or column explains that there's a relationship, that this genre ID links to the genres table in its ID field. So it's another way of showing that there's a relationship between those databases, those tables specifically. And we have our indices on that, and we have genre ID has a link to genre ID and book ID. Oh, that's not correct. Looks like I accidentally bumped a button and hit OK. I'll have to remove one of those indices because I only want one of them. So I'm going to have to go back and fix that. Oh dear. Fixing things. How bad. And then the same thing right here, our author links to the author's ID, and our genre has that quick, easy set. So let's go ahead and we're going to close this. We'll go fix that extra index that we don't want on there. That'll also give us something that we can do to actually fix this. So I'm going to go to my books genres junction field over here and bring that back up on this. And if I go over here and on my indices list, I have my only book ID and genre ID. I don't see it right there. Ah, there it is. It's on the genre ID. So genre ID only links to genre ID. So I dropped that extra index that was listed on there for that individual field. So my book ID has only the book ID linked to that. And my genre ID only has my genre ID linked to it. So I have the correct index matching right there. So again, let's go ahead and let's take a look at that so we can see how that looks as a whole. Back to their database reading, go back to my data dictionary print view. And I scroll back down, and my book ID links to only book ID. My genre ID only links to my genre ID. Okay, so I fixed my indexes properly so I have the right set of indexes on that. So that was me accidentally clicking something that I shouldn't have. Okay, caught it now. It's not going to cause any problems, no big deal for us. But that print view allows us to check some things out and actually see the way things are supposed to be set up. So this is our structure we're going to be using for our class for that. We have, as we can see right here, that's the same basic setup we've been using throughout everything in class. You can see right now my total database right now is 112 kilobits or kilobytes. So it's really, really huge right now. There's nothing in there. It's just storage to hold it all together. As we start looking at this, we're going to see the database get some increase in size. And our query that we're going to be looking at for the idea of timing, like we talked about last time, we're actually going to start seeing that it's going to take time to execute as we start adding more data to this database. And so this framework right here is going to be given to you as part of the server. So you'll be having access to this entire database, and I'll also be giving you the SQL queries. You could build it yourself if you wish to. So you could try playing around with how it was built to set up these relationships. You'll have access to the full SQL for that. But you will not be able to have any editing features on the structure on that. So your DDL language, your data definition language, is not going to happen. You only have DML access to this data as part of your login. So I'm going to be only allowing you to insert and update data with your account. My account will be able to access the entire structure, but you guys are only going to be able to change the data inside it. And so you guys are going to see what it takes to actually do that.